All right, ladies and gentlemen. So, Mr. Gotch here, giving you guys the lesson from home. Again, my family is completely quarantined for coronavirus. So, I will be at home for a few days and hopefully join you sometime next week. So, today we're going to learn Chapter 5 standard form. That was planned for yesterday, but I got called out. So, we are going to get rolling here. So, we're going to start with a little warm up. Okay. If you take a look at the warm-up, we're going to write the equation of a line in point slope form, satisfying these given conditions. And we're actually going to start with number 2 because I think this is the easier of the two. The reason why it's the easier of the two is because if I'm putting in point slope, I need two things. I need a point, which we have, -3, -5, that's x1, y1, and I got my slope, which is -2. And now all we're going to do is just plug it in, plug it in. I have y minus y1, so y minus a -5 is +5. When you subtract a negative, it makes it positive. And then I have my slope is -2. And then I have x minus x1, so we take a look, x1's -3, so x minus a -3 is +3. And that's fine to go right into that step. There you go. That is point slope form of that point and that slope. Now, when I go back over to number 1, this one's a little bit more trickier because, again, I'm trying to put it into the point slope, but they gave me 2 points. I got a point, but I don't have the slope. But I do know how to find slope. So this is where we grab our picnic table and our margarita glasses, or if you're James Bond, the martini glasses, and you got to be 21 to drink. We got y2 minus y1 all over x2 minus x1. I always like to label these guys. x1, y1, x2, y2. Again, these are coordinate points. This is my first point. That's my second point. And now we're just going to plug those guys in. So y2 minus y1 is 1 minus 0. And x2 minus x1 is -2 minus 4. We do a little simplifying. 1 minus 0 is 1. If you owe me $2 and borrow $4, now you owe me $6. And there's my slope. Okay. So now I have a point and I have my slope. Now you can use any point you want up here. I'll probably 99% of the time use the first point. And now it's back to where we were over here. Okay, so I'm going to switch gears. I'm going to switch colors on us. I'm going to plug this right into y minus y1 equals m times the quantity x minus x1 and plug this in. So as I take a look, I got my m, I got my point, x1, y1, and now pluggy chuggy, right? So I have y minus 0. I got m is -1/6, and x minus x1, that's x minus 4. If you leave like that, that's not too bad. I do prefer that you simplify the y minus 0. Y minus 0, y minus anything is just y. And that equals -1/6 and then x minus 4. Again, if you left it like this one here, I accept that, but I do actually prefer this one. Okay? Just get you thinking of simplifying. All right, ladies and gentlemen. So that was great review from our last section. And now we're going to move on to our goals for today. So today we're going to take a look at something called standard form, and we're going to look at linear equations using x and y intercepts. And we're going to write linear equations in standard form. And then last but not least, one of the last things we do, we're going to look and write and graph equations of horizontal and vertical lines. Okay, so let's go ahead and get started. Here's the new stuff. As I take a look, standard form of a linear equation line, a standard form equation looks like this. ax plus by equals c. Okay, so to give you an example with numbers, it's like 7, I'm just making this up, 7x plus 5y equals -10. Okay, this is an example of a line in standard form. The numbers a, b, and c, these guys right here, are just numbers. So a, b, and c are just numbers. Okay, now what type of numbers are they? we want A, B, and C to be integers. Okay. What are integers? Integers are nice, pretty numbers. So like 2 and 1 and -7 and 100. Okay. So we want A, B, and C to be nice, pretty integers, which means no fractions, no decimals. So if we have fractions and decimals, we can go ahead and change those. Okay. And we'll show you what to do with that. All right. So new form. Now we have point slope form, and now we have standard form. Okay. So as we take a look, walking our way through our notes, standard form of a linear equation can be used, very useful for graphing. When the equation of a line is written in standard form, it is quick and sometimes easy to find both the x and y intercepts. So I always say, what's standard form good for? And a lot of you guys will say, nothing. You're funny. It's good for something. It's good to find x and y intercepts. Now, what is an x-intercept? An x-intercept of a graph is where it crosses the x-axis. Okay? And an x-intercept is written as an ordered pair, and you're going to get a number here for x, and you'll get 0 for y. So an x-intercept is where it crosses the x-axis, so that means a y-intercept is where it crosses the y-axis. And we can write that as an ordered pair. A y-intercept written as an ordered pair is 0, comma, some number. Okay. All right. So we can find x and y-intercepts very easily. To find the x-intercept, we're going to plug in 0 for y. And to find a y-intercept, we're going to plug in 0 for x. And we're going to call this the cover-up method, and I'll explain that next. All right, so on the next examples 3 and 4, we're going to investigate looking at graphs and identifying x and y intercepts. Remember, this guy right here going across is the x-axis. So I'll put that on both of these here. And the up and down one is the y-axis. So if I want the x-intercept and the y-intercept, we're going to take a look at these two graphs and figure out where it crosses or touches the x-axis. So as I take a look, here's the x-axis. Here's the dot right there. I just got to be able to identify what that coordinate point is. So starting at the origin, that's to the left. So that's -1. And an x-intercept always has y 0. And if I take a look, the y-intercept, we're going to assume crosses right there, that perfect corner right there. That guy is up 1. So that is 0, comma 1. All right. So this goes back to everything we learned in 5.1, looking at coordinate points and identifying what those coordinate points are. And there we go. Final answer. X-intercept -1, 0. Y-intercept is 0, 1. So as I take a look here at number 4, I like making big old dots where those guys are. I want to find the x-intercept, and I want to find the y-intercept. So as I take a look, find the x-axis and find where it crosses or touches. So I'm going to count 1, 2, 3, 4, 5, 6, 7. I get 7, 0. And then this guy is the y-intercept. 1, 2, 3, 4. That guy right there is 0, 4. So after this, you should be able to look at a line and identify where it crosses the x-axis or the y-axis. And these are your x-intercepts and y-intercepts. Okay. X-intercept is when y is 0, and y-intercept is when x is 0. All right. So in the next group, examples 5 through 10, I'm not going to do every single one, but we're going to go through and determine the x and y intercepts for each linear equation. Then we're going to graph the line using those intercepts. Okay, so again, a reminder, if you're looking for the x-intercept, that's when y equals 0. And when you're looking for the y-intercept, that's when x equals 0. Okay, so this is where we're going to call this the cover-up method. Okay, so I'll explain that. X-intercept is when y is 0. I'm going to go ahead and plug in 0 right here. Well, if I plug in 0 right here, negative 2 times 0 is like it's not even there. We could literally like just cover it up and write what's there. So if I plug in 0 for y, I cover up. Let me use a pen so I can cover it up. Negative 2 times 0 is like nothing. And now I just get x equals 12. Okay, so when I'm looking for my x-intercept, just cover up the y, and that allows us to solve it. So we get x is 12, so I'm going to write that as a coordinate point 12, 0. Okay, and if I want to find the y-intercept, I'll do y-intercepts in red. Y-intercept is when x is 0, so go to the x and cover that guy up, because it's like 0 minus 2y. Well, 0 minus 2y is just negative 2y. You get negative 2y equals 12. Just cover up the x value, because again, we're plugging in 0. Go ahead and divide this guy. Solve for y. Divide by negative 2. And we get y. 12 divided by negative 2 is negative 6. So we were going to write that as 0, negative 6. Okay. Now, if I look at all these boxes that I've given you, all the graphs that I've given you, there is only 10 boxes going across and up and down. So there's only 10. Well, if I'm trying to graph 12, 0, that's kind of hard to do, okay, when there's only 10 boxes. So that means I've got to count by 2s. That way, 10 times 2, that gives me up to 20. All right, so this represents 12 zeros, my x-intercept. Here's my x-axis. 2, 4, 6, 8, 10, 12. There it is. And I'm going to write 12 there. Okay. And if I do it for the x-axis, I'm going to count up and down 2 for the y-axis. Okay. So 0, negative 6, I'm going to go down 2, 4, and negative 6 is right there. Okay. Now, if you got a straight edge, use your straight edge. I've got a calculator here, so I'm going to use my little calculator as my straight edge. And I'm drawing my line. Just connect the 2 dots. In geometry, you guys are going to learn that 2 points determine a line. So once you have your 2 points, we're good to go. All right, so let's do another easy one. Let's jump down to number 8. I'm going to skip around on this page. Okay. So again, I want my x-intercept, and I want my y-intercept. So we're going to jump to number 8 here. So x-intercept is when y equals 0. So cover up the y's, because negative 14 times 0 is like nothing. So I'm going to cover that guy up and see what's left. My fingers are too big, so I'm going to use a pen here. So I cover that guy up, and that gives me 7x equals 28. So 7x equals 28. I'm going to go ahead and divide by 7. 7 times x, the opposite of times is division of 7. So I get x equals 4. All right, that's a coordinate point. That's 4, 0. All right, I just got to do it one more time. I'm going to do the y-intercept. The y-intercept is when x equals 0. So I'm going to cover up that x. 7 times 0 is nothing. So I'm going to cover that up and write what's left. If this is a negative, I'm going to leave the negative there with the 14. Negative 14y equals 28. Okay. I'm going to go ahead and divide by negative 14. And then I have y equals, I got 28 divided by negative 14 is negative 2. Okay. So I'm going to write that as a coordinate point. I've got negative 2, 0. Now, I can fit both of those points on by just counting by ones. So 4, 0, I'm going to count over. 1, 2, 3, 4. That's 4, 0. And then, if you notice, there's a mistake. Mr. Gotch wrote this backwards. It's 0, negative 2. Sorry, guys. Hopefully you caught that. So I'm going to count down 1, 2. So there's negative 2. 2 points determine a line, so go ahead and use your straight edge and connect the dots. So again, we have an x-intercept of 4, 0, and make sure you have this as 0, negative 2. All right, x was 0. X comes first. Right. And there we go. And let's move on to a harder one. Okay, so 5 and 8, not too bad. Let's take a look at a tougher one. Let's look at number 6. Okay, so as I take a look at number 6, I've got 3x minus 5y equals 9. Again, we want to find our x-intercept. We're going to plug in 0 for y. So cover that guy up and see what I got. And that one's not too bad. I get 3x equals 9. And if I want to get that x by itself, I'm just going to divide over the 3. And I get x is 3. And again, I want you guys to write that as an ordered pair. That's 3, 0. Okay, so that one's not too bad. It's the next one that's a little tricky, but not too bad. As I take a look, I get y-intercept is when x is 0. So I cover up my x's, and I get negative 5y equals 9. Now, when you take a look at this one, you're like, oh my gosh, when I divide over, oh man, I get a fraction. Okay? So you can write that as y equals negative 9/5, but what is negative 9/5? If I'm trying to graph that point, I'd want to know what that is. And that's where you just grab your calc. Okay? So you can just type that in, negative 9 divided by 5. You know, for me, I need to see the decimal, so I understand where to put that point. And I get y equals negative 1.8. So if I'm going to write that as a coordinate point, that's 0, negative 1.8. Okay. So just negative 9 divided by 5, that's negative 1.8. And now I can graph this guy pretty easily. Okay, so 3, 0 in blue. Count over 1, 2, 3. And then if I have 0, negative 1.8, I'm just going to go down 1, not quite to 2. Okay, 1.8 is really close to 2, just not. I'm going to label that guy. Okay. 2 points determine the line, so you got 2 points, one on the x-axis, one on the y-axis. And now we got our graph here. Okay. Just a reminder, these are all, so far, been positive slope. All positive slope. Okay. All right. I'm going to take a look at number 9 now. I'm going to skip over 7. I think that one's pretty easy. So let's go to a little trickier one. Okay. So the first thing I would say, is this standard form? And a lot of guys are going to say, no, it's not. Remember, standard form have the x's and the y's on the same side and then the number all by itself on the right. So you could go ahead and move this x over. So we get the x's and y's on the same side. I'm going to go ahead and do that. I'm going to add the 2x over. So what I now have is 2x plus y. These are unlike terms. I cannot combine them, so I leave them separate. And now that's equal to 4. And now the cover-up method is pretty easy, right? So again, let's do that down here. I got the x-intercept, and I got my y-intercepts. All right, x-intercept is when y is 0, so I'm going to cover up that y value. Use this pen here for you. And that leaves me with 2x equals 4. And then I'm going to divide by 2. So I get x is 2. So I'm going to write that as a coordinate point, 2, 0. So that's not too bad. So if it's not in standard form, just move it over so it is, and it makes it very easy using the cover-up method. If I plug in 0 for x, 2 times 0 is nothing, so I'm going to cover it up. And now I've got y equals 4. And write that as a coordinate point, 0, 4. All right. So I go ahead and graph those two guys real quick over 1, 2. And then up 1, 2, 3, 4. So positive 4 there. Okay. Go ahead and graph that guy. Connect the dots. 2 points determine a line. And there we have it. All right, so ladies and gentlemen, if it's not in standard form, get it in the standard form, and it just makes it real easy. Okay, so same thing on number 10. I'm not going to do this one, just talk about it. If I was going to solve this one easily, I would add the 3x over. Okay, so that it looks like standard form where the x's and y's are the same side. And then now I can use the cover-up method. Some of you guys are so smart, you could do the division in your head. You cover it up and say, well, I know what negative 9 divided by 3 is. That's negative 3. And then negative 3 again for the y. Okay. Make sure you come up with 2 points. 2 points to determine a line. So an x-intercept and a y-intercept, those two values you get for x and y are 2 separate values, 2 separate points. All right, ladies and gentlemen. All right, ladies and gents, let's finish up this last page. We got horizontal and vertical lines. Okay. It says here a linear equation of a vertical line which has a slope that is undefined, which means it has rise over no run through a point x comma y is going to be an x equals line. Now, what's the x value going to be? What's this number over here? It's whatever the x value is. So I'm going to say x equals x sub 1. It's going to be a number. Okay. So as we take a look, it says write an equation for the vertical line passing through the point 2, 3. So the first thing I'm going to do is graph 2, 3. So I'm going to count over 2 and then up 1, 2, 3, 2, 3. That's right there. Well, vertical line, you guys got to know what a vertical line is. Okay. When I think of vertical, I always think of basketball players and their vertical leap. A vertical leap, when we measure that, is how much they jump up and down. All right. So all I'm going to do is make a line going through that point up and down. And if you have a straight edge, you can use that. I'm just going to freehand it. Okay, so I got a nice vertical line up and down. And then we want to come up with the equation of that line. Well, this is a vertical line. It's an x equals line, and it's whatever the x value is. If I take a look, it's where it crosses the x-axis, and that's at 2. Now, the reason why it's called an x equals 2 line is because every point has an x value of 2. This guy right here is 2, 0. This is 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, da, 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 da. Just keeps going. Okay. The last one is the horizontal line. This is a linear equation of a horizontal line, which has a slope that is 0 slope. That means no rise over a run through a point x1, y1 is going to be a y equals line. So it's going to be a y equals some number, and that number is always going to be the y value. Okay. So if I take that exact same point that we just had, it's a horizontal line going through point 2, 3, 1, 2, 1, 2, 3. There's only one line that is a horizontal line through that point, and that goes straight across through that point. Now again, it crosses the y-axis at 3. This is a y equals 3 equation. So again, it's the y value. The reason why it's the y value, every point on this line has a y value of 3. For example, this is the y-intercept of 0, 3. This is 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3, dot, dot, dot. Okay. Now, it's always hard to get these focused and make sure you have this correct in your mind. So to help us get this straight in our mind, I think of the alphabet. And starting with U, V, W, X, Y, and Z. You guys know the alphabet. Okay. I always remember this side. If it's a Y equals line, okay, so if it's Y equals a number, then I know this is going to be a horizontal line. All right, horizontal. It's a horizontal line with 0 slope. It's fun to say. 0 slope is horizontal. Okay, and again, what is a horizontal line? It looks like the horizon. It has Z's in it. So Y is right next to Z in the alphabet. A Y equals line has 0 slope. 0 slope is a Y equals line. That's a horizontal line like the horizon. If it's an X equals line, X equals some number. Okay, don't need the W. I'm going to cross that out. An X equals line, like we had in example 11, that's a vertical line. And that's U and D slope, undefined slope. Okay, I always remember this side. If I know YZ, Y equals is horizontal, 0 slope. I always remember the other one too. Also, I always remember UV, WX. UV, like UV rays, is undefined and vertical, and that's an X equals. All right, ladies and gentlemen, last thing we're going to do is we're going to take a look at these 3 quick equations and try to get those guys into standard form. So we're going to rewrite these equations in standard form. The reason we want to do that is so that they're easier to graph. So if you take a look, everything here is in point slope. Okay, and we want to make it look like standard form where it's ax plus by equals c. And again, we want a, b, and c to be nice, pretty numbers. Okay, nice integers. So if we have any fractions, we're going to have to change that. Okay, so notice x and y are on the left side and the constant, the number all by itself is on the right. Okay, so as I take a look at 13, we take a look, and the first thing I notice is I want to get rid of these parentheses. And to do that, we're going to use the distributive property. So this is great practice. 2 times x is 2x. And 2 times 3 is 6. Okay. Well, again, we want the x's on the same side as the y, so we're going to move this x over. Well, how do I move a plus 2x over? What's the opposite of plus 2x? And that's minus 2x. I'm going to put it out in front. Okay, notice the x comes first, so I'm going to put this x first. So I have a negative 2x. I have a positive y, so I'm going to put a plus y here. These are unlike terms. I got to leave them separate. Minus 2, and that equals 6. Okay. Last thing I need to do is I need to move this little constant over. So as I take a look, I want to move negative 2 over using addition. So I'm going to plus the 2 over. Okay, so I end up with negative 2x plus y, and 6 plus 2 is 8. Okay, now for me, this is perfect. Okay, I like this form. I have nice, pretty numbers in front. But in the answer key, you'll probably see that they make this guy positive. They make a big deal about trying to make the leading number, which we call a coefficient, the leading coefficient, positive. So for me, this is okay. Okay. If you want to change every sign, go ahead and divide everything by a negative 1, both sides. And when you divide everything by a negative, you'll get 2x Y divided by negative is negative y, and 8 divided by negative 1 is negative 8. Okay, that's perfect standard form where the leading coefficient is positive. For me, I don't care. Either way is fine. All right. So I do want to show you 14 and 15 before we leave here today. 14, I'm going to show you a little trick. When you have a fraction in front and you need standard form where we don't have fractions, we're going to take the numerator, and if there's a negative, we're going to keep the negative with the numerator. And we're going to distribute this guy over here. That's a little trick I'm showing you. So negative 3 times x is negative 3x. And negative 3 times 5 is negative 15. Well, Mr. Gotch, what do we do with this 5? Well, we're going to take this 5 and multiply it to the other side. And when we do that, we distribute over there. So you distribute the numerator on the right and the denominator on the left. So we get 5 times y is 5y, and 5 times 1 is 5. Okay? I like to call this a little math magic. Basically allows us to get rid of those fractions. Nobody likes fractions, so let's get rid of those things, and it's going to make it easier. Make sure you keep the negative with the numerator. Okay, negative and numerator are teamed up, and that's partly because on the next step, we're going to move our x over, right? We want the x on the same side, so we're going to add 3x over. Okay, and what I get now is I get a 3x. This is a positive 5y, so put a plus in between, and then plus 5. And now this guy's canceled. I get negative 15. And now I have one more step. I want the x's and y's by itself, which I have, except for this 5. I want to move this guy over. So I'm going to use subtraction to do that. Go ahead and subtract that guy. I end up with 3x plus 5y. And if you owe me $15 and you borrow 5, now you owe me $20. So negative 20. That's perfect standard form. All these guys are nice, pretty numbers. The reason why they're nice, pretty numbers is because we got rid of this fraction earlier by distributing the denominator to the left. So numerator and the negative stay to the right, and the denominator gets distributed to the left. Okay. Last but not least is number 15. I've got y equals negative 2x minus 1. Again, we want that x on the same side. So we could get rid of this fraction first, but I'm going to go ahead and do that last. Okay, just show you what we need to do. So I'm going to go ahead and do the opposite of minus 2/3 x. I'm going to add 2/3 x over to both sides. I'm doing that so these guys are canceling. So again, these are unlike terms. I've got 2/3 x plus y, and that equals negative 1. Okay, we're almost done. Almost done. We have our x's and y's on the same side. We got the constant all by itself. The problem is this 2/3. All right, they want a, b, and c to nice, pretty numbers. Well, the reason why it's not a pretty number is this 3. So to get rid of a division of 3, we're going to multiply everything by 3. If you do it to one thing, you got to do it to everything. The idea is you're doing it to both sides. When you do it to this side, you got to distribute. And what happens is these two are going to cancel, and that leaves me with 2x. 3 times y is positive 3y, and 3 times negative 1 is negative 3. Okay. All right, ladies and gentlemen, that was notes for today. If you guys have questions, you can always feel free to email me. Take a look at the Math Lit Center. There will be people down there for you. I have the Chapter 5.5 worksheet ready for you guys to go for homework tonight. So give that a shot. And we'll have you guys do the odds for homework for the worksheet. So again, just the odds, and I'll put that on Canvas for you as well. So odds on the worksheet. When you come back in tomorrow, you'll have some time to finish that up and work. There's also an IXL assignment for Friday. So you guys have a great day. I'll hopefully see you next week.